Hey guys, how's it going? Today's lesson is 10.1, 10.2, and 10.3. Today we'll be talking about scale drawings, using maps and making scale drawings. That's why the lizard said it sounds personal, because of the scales. You get it? It's like a, okay, yeah. All right, we'll just keep on moving. Proportion, relationships, and scale. I'm on page 1 and 1 in your book. You should have your book out. What we're basically going to do is talk about representing proportional relationships using equations. Remember, an equation has an equal sign. We're going to determine the constant of proportionality, which just means it goes up equal amounts every time. And we're going to solve problems using scale drawings, not the lizard, but scale. And basically all this is really talking about is fractions. We're setting up fractions to display that data. Flip over to page 102. Put a little star by this box, writing math. It talks about another way to write proportional relationships as an equation in the form y equals mx. You're going to see that formula a lot. Learn it, know it, live it. Basically, all I'm saying is I have two numbers. X goes in, it's multiplied by a constant, and the outcome is the answer from that. So like if the cost of a flag is X, $5, if the X is the number of flags purchased, the equation y equals $5 times X could be used to determine the cost of flags. So if I have 10 flags times $5, I owe $50 for those flags. I'm on the next page, but you're still on page 102. We're going to look at number 3. It says complete the following table, which displays the correct hoist and fly of the U.S. flag according to the flag code. Hoist and fly sound like a couple of weird words. Over here, as you can see, I've got my American flag. Fly is just the amount that it goes out away from the pole, and the hoist is just how big the flag is. I got the little fly guy there. I think the lizard down here would love to have that flag. But basically, they're just using complicated words to say length and width. I'm going to fill out this chart. We're going to use this equation right here. It says our step is hoist over fly. So hoist goes in. Whatever I got, it's 1.9. So if 1 goes in, 1.9 comes out. 2 goes in, 3.8 comes out. 3 goes in, 5.7. So copy down these numbers. And that's basically just putting these numbers into the equation. I also completed it the other way, where they give you the answer and you have to solve for the variable inside. 8.9, 10, 13.2, and 20. Hoist over fly. But they're just giving you some complicated words for putting those numbers in using this equation. I know, always trying to trick us. You got it copied down? All right, great. Moving on. We're on page 103 right now. I'm going to start out by putting a star by this box. The relative size of two items shows how the size of one item is larger or smaller than the other item. For example, the relative size as a baby is small next to a full-grown adult. Doesn't seem too complicated. Let's go over to our problem. Sometimes a scale drawing is used to represent the data or problem shown the relative size of two items. Look at the drawings below to solve. So again, we've got our hoist and our fly. Hoist and fly. And these are proportional, right? Hoist over fly. So let's write a proportion to represent that drawing. And remember, it's not as important that you get them in the exact right spots as long as you keep them consistent. So I have 3 over 5, hoist over fly. I just made a fraction there, 3 over 5. And I know the hoist of this one's 9. I put that there. And I don't know that, so I just put an X there. X is like a question mark, right? So as you notice, I got hoist over fly, hoist over fly. We just don't know the fly. And then they're asking us to basically solve this equation, and we know how to cross, multiply, and divide. We go like that, and we go like that. And we know we got 3x on this side equals 5 times 9 is 45. And that's what I've got right down here. 3x equals 9 times 5. 3x equals 45, or I could say x equals 15 when I solve that. And I know everyone listening to this can solve that problem. So it's easy. We're just cross-multiplying what we've been doing for months. Let's keep on moving on. All right, I'm on page 104 now. I know you'd be happy that I'm cutting out a lot of information here for you. I'm going to put a star next to this. A scale drawing is a figure or copy with all the lengths the same. When it's the same ratio, that means corresponding lengths are the same. So if you look at this drawing, I've got A to B right here, and it's equal to, proportionally equal to, P over Q. And then I got B over C right here, and that's proportionate to this. It's the same side. I'm comparing this side to this side to this side, and they're proportional. I also made another drawing down here, a flag I did. This one's 2 and 4, so this would be 6. So you know those are proportional, and we don't know that one, so I set up a proportion again. I have 6 over 2 equals, I don't know that, so that's for my variable, and I put that over 4. And then it's not hard to solve that. We know cross multiply, and solve for the variable, right? We are getting so great at that. So I've got 2x equals 24, or x equals 12. Give you a second to make sure you got all that information. All right, I'm on page 105. Probably the quickest lesson we've had. Now we're going to talk about scales of maps, distances, and finding the actual distance, and we're going to convert those into unit. Remember, unit means for 1 unit scale factors. They give us a proportion here, inches to miles. So on a map, 1 inch equals 100 miles. You can't have an actual map with actual size. Where would you put it? A map from here to my house would be, 5 miles long. I wouldn't even be able to get it in my Jeep. Let's go through a couple of these examples. It says write the proportion to find the number of miles from Boston to Philadelphia if the distance on the map is 3.08 inches. Well, we know that 1 inch is 100 miles, right? It tells us right here, 1 inch is 100 miles. So how big is 3.8 inches? That's easy. We set up a proportion. They tell us 1 inch equals 100 miles. We put our inches. Notice the inches are lined up, and the part we don't know is right here. So 1 over 100 equals 3.8 over 0. The next part, you guessed it, we're going to solve that. It's 308 miles. How did I get that? I knew you were wondering that. I multiplied here, and I multiplied here. So basically, it's like getting x, if I could make this question mark an x equals 308. So if I see 3 inches on a map, it's 308 miles according to that map. The next stop was Washington, D.C., which is 1.38 inches farther. So you got to get the total mileage. They're adding a little part on. You got to read that carefully. It's 446. Adding that to the number we get, we compute the second part. I put that question in there just to realize you have to read the questions carefully. Sometimes people jump to the answer and assume it's that, but you've got to read carefully to make sure you're answering the question exactly. Let's keep going. Uh-oh, we're going all the way to page 109. 109. Your book says the New England Patriots, boo. Nobody likes the Patriots. I could have put the Colts in there, but, I was feeling a little salty, so I put the Bears in, the greatest professional football team of all time. The Bears are a professional football team. Some information about the football field is given below. The dimensions of this field are 160 feet by 360 feet. The end zone is 160 feet by 30 feet. Remember, I know people are saying yards, yards. Well, we're going to use feet. 10 yards is 30 feet. The upright goalpost is 10 feet off the ground. Makes you realize when guys dunk the ball over the goalpost that they're actually getting up there. Same as a basketball hoop. And the width of the upright is 18 feet by 6 inches. Now we're talking about scale. What are the dimensions of a field that is drawn 1/8 of scale? Well, how did I figure that out? Well, they tell us what our field is, right? They tell us our field is 160 feet by 360 feet. So to find out the scale of that, I divided the top and the bottom. Since it's 1/8, I divided the top and the bottom by 8. And if I do that, I get 1/8 scale. Well, those equal this number. 180 divided by 8 is 20. 360 divided by 8 is 45. But that is 1/8 scale. I'm dividing. They told us to sketch and label a diagram of a football field reproduced at 1 1/4 scale. Those measurements would be 20 by 40. I took these measurements, 160, and multiplied it by 1 1/4. Notice I switched that to improper for multiplication. Remember, we just put the number over 1, cross multiply and divide, or multiply across and then divide. And then I took the other amount, 360, did the same thing, multiplied that by 5/4. And that is how I got 200 by 450. And of course, I'll put feet on there because we always label story problems. So look what we're doing. If we're making it bigger, because obviously you couldn't draw this, 400 feet long would be a huge piece of paper. When it says to make it bigger, we're multiplying. When it says to make it smaller, we're dividing. Divide, smaller. Multiply, bigger. Go Bears. Last problem. Then I'll turn you loose and let you do some on your own. Hey, Fly Guy. I'm on page 111. Actually, I'm on page 110. Don't be confused. I was so excited about the Bears, I made a mistake. A book cover is 8 inches by 10 1/4 inches. What are the dimensions of the cover when it's reproduced for 1/12 scale? We're going to divide both sides by 12, right? So I have 8 divided by 12, which is really like multiplying by its reciprocal, right? So I have 8 times 1/12, 1/12 scale. And 4 times 10 is 40, plus 1, 41/4. We're going to multiply both those by 1/12 scale to get the dimensions of the book. And in my super mathematical brain, the answers are 2/3 inches by 41/48 inches. And all I did was 8 times 1, 1 times 12. Reduce that fraction, I got 2/3. 41 times 1, and 4 times 12 is 48. So when you're making things bigger or smaller to scale, not like a lizard scales, but to scales, you're just multiplying or dividing by fractions, which we all know how to do. Hey guys, time to get your homework ready. It's in the back. Have a great day. I'll see you soon.